So in this video, we take a look at the toon shader. In this scene, I have this simple distant light, a floor object that has a shadow matte shader, and a background geometry with a flat shader assigned to it. You don't need to worry about how the scene is set up. We'll be talking about these shaders later on. The only thing you need to know is this distant light that works as the only light source in the scene, and it comes from above with a slight angle. We might change things as we move along in the lesson. So let's create a toon shader in the material manager. From the create menu, Arnold, surface, and toon. Assign it to the sphere and the car and open up its network. Toon Shader is a non-photorealistic rendering solution to render edges, lines, and toon/cell shaded looks to achieve illustrative and technical images, for example, for like a halftone or comic looks. It has tons of options and I won't be covering everything here. I just go through the basics and you can check out Solid Angle website for detailed documentation. The shader has a lot of components: edge, silhouette, base, specular, stylized highlights, rim lighting, transmission, sheen, and emission. We are mostly interested in the edge and the base components. Now let's start with the base and turn off the edge contribution. So base controls the diffuse or base contribution color of the shader, or how bright the surface is when lit directly with a white light source. Keep this last part in mind as we get back to it in a moment when discussing the tone mapping color. You can choose any color and with weight control the overall contribution of the base component. For now, set the color to white. Now, tone map is where it gets interesting. Tone map lets you assign a ramp or a gradient with bunch of colors, and depending on how bright a particular area of the surface in relation to the light source is, different color of that ramp will be used. Let's add a ramp RGB node and load this preset called Toon YP and connect it to the base tone map input. Also change the ramp type to U. If you take a look at the sphere, and just one quick tip, in the IPR I have the progressive rendering turned off because the edges and the lines are rendered at the final stage of the rendering, and when progressive rendering is turned off we can see the final stage of the rendering immediately without having to go through the progressive refinement. Now if you take a look at the sphere and think about the angle of the distant light, where the sphere is hit directly by the distant light, we get this yellow color from the right side of our ramp RGB node. And as we move from the directly hit areas to the shadows, we go from this yellow to orange and finally to this pink color. And you can see the exact same thing in the car as well. This ramp has a step interpolation. If you are looking for a more gradual color change, you can choose the smooth interpolation. For now, let's use the step interpolation. I can move these nuts on the ramp as I wish, or even add more color. Maybe let's add a green color, for example, between the yellow and the orange colors. So that is really the basics of tone mapping. You assign a ramp, you define the colors from right to left. The colors on the right will show up where the light hits directly and the surface is brighter, and the colors on the left will show up where the light can't reach directly and the surface is not that bright or in the shadows. For now, I'm going to set the base weight to 0 and emission weight to 1 and open up the edge section. To render any edges, first you need to make sure in your render setting the filter type is set to contour, or you won't be able to detect and render any edge on your geometry using the toon shader. And this filter width here controls the limit for the width of the detected edges, and they cannot have any bigger width than the value defined here. 2 is enough for now. Let's get back to the shader and enable the edge detection. You have color, which controls the color of the edge. Opacity controls the visibility of the edge. Width scale controls the width of the lines, and this is a multiplier for the filter width in the render settings. So if I set the filter width in the render settings to, let's say, 6, now we're gonna get a much thicker line, but I can multiply it by a width scale less than 1 to get a thinner line. As you increase the filter width, the sampling will take longer, so make sure you stay at a reasonable range. I'm gonna set the filter width to 2 and width scale to 1. In the edge detection section, a very important parameter lies, which is angle threshold. If we start decreasing it to less than 180 degrees, we start detecting more and more edges, as the toon shader uses the difference of the angle between neighboring pixels. So the lower the angle, the more edges will be detected based on the topology of the geometry. For now, set the angle threshold to something like 5 degrees. Another important parameter here is the mask color. By assigning a texture like a noise texture to the mask color, you can essentially ignore the underlying topology of the geometry and draw a line anywhere. Press Ctrl Tab and let's search for a noise. Add a C4D noise. Set it as the beauty shader. Change the noise type to something like Sema, and space from texture to world, and set the global scale to 500%. Now we can use this noise to draw lines. The toon shader will detect value difference between neighboring pixels and draw a line. Now I'm going to set the noise as the edge mask color and set the toon shader as the beauty shader. And there you have it. It does not have to be a noise, it could be anything else. Let's add a checkerboard pattern, for example, and set it as the beauty shader. We don't have very usable UVs on this geometry, so let's add a triplanar after the checkerboard and set the triplanar scale to something like 20. And in the checkerboard pattern, set the U frequency to 30 and V frequency to 8. Now connect the triplanar to the mask color input and set the toon as the beauty shader. And now we have added tons of new lines to geometry based on that checkerboard pattern. Another important option in the edge section is the tone map, which works exactly like the one in the base section. As we learned, for the tone map to work, we need the lighting information of the geometry, where the light source hits directly, where it does not, and for that we need to have the base weight set to bigger than 0. Let's set the base weight to 1 for now, and disconnect the ramp RGB from the base tone map and connect it to the edge tone map. And because the tone map color information will be multiplied by the edge color, we need to make sure the edge color is set to white if we want to get the exact colors from the ramp RGBA. For now, let's delete the orange color to keep it simple. And as you can see, the same thing happens here. The edges that are hit directly by the light source are using the color on the right, which is yellow, and the edges that are not hit directly or are in shadows use the colors to the right of the gradient. For now, let's disconnect the checkerboard pattern from the mask color. Then we have the silhouette component, which draws a line around the silhouette of the individual geometries. Let's zero out the emission weight for now. And now we only have the base color and the edge lines. I'm gonna quickly go through the rest of the parameters. If you want a deep dive, definitely check out the solid angle documentation. A quick tip: Each shader has this help menu that has a help button that sends you to the documentation page of that shader on the Solid Angle website. Now, specular weight controls the amount of specular reflection, and as I increase the specular weight, we gradually start to ignore the base component, and at one, base contribution is completely ignored, and at this point the edge tone mapping is as well gone, and that's because, as I mentioned, the tone mapping is based on the lighting information on the surface of the geometry, and base component gives us that info. When it's disabled, we don't get that data, therefore tone mapping will not be possible. We normally want to use a value less than 1 for the specular weight, and the rest of the parameters here should be very familiar to you, as we'll learn about them in the standard surface shader. For now, set the specular weight 2.5. Stylized highlights allows you to define a texture and a light to draw a stylized highlight on the surface. Let's add a point light close to the sphere. Add it to the lights list under the stylized section. Now add an image node, unload this window stylized texture. Any texture you use here should have this black empty area because a circle will be drawn from the center of the texture that goes to the edges of the texture, and only the content inside that circle will be used. Now connect the texture to the stylized color. And now that window appears on our geometry as a stylized highlight, and size value here can be used to make the highlights bigger or smaller. Then we have this rim lighting section, which gives you a rim light shading effect based on the specified light. So drag in the distant light. Change the color to something visible like blue. And increase the width to start introducing the rim light effect. Let's zero out the width. For now, set the specular weight to 0. This transmission, sheen, and emission sections work exactly like their counterparts in the standard surface shader, so I'm not going to discuss them here. So that's about the fundamentals of the Arnold Toon Shader. As I mentioned, if you are more interested, do check out the documentation, as it has way more in-depth information than what it was presented here. So in this video, we learned about the Toon Shader. See you in the next one.